Okay, so we're going to continue our study of center and spread with statistics, and our focus today is going to be learning about standard deviation. So that's our objective. Oops. Why do I always leave it in green? That's so weird. Our objective is to understand and calculate standard deviation for a set of data. So what I'm going to do is first give you a definition of standard deviation. I'm going to show you the formula. It looks very scary, and then we're going to do out an example, and you realize it's not that difficult what we have to do. It's a little bit of work. It's a lot more work than what we had to do, but it's not hard work. Okay, and it incorporates a lot of things we've covered, which is good review at the same time. So what is standard deviation? Well, if you deviate, that means you go away from the norm, okay? And standard means it's regular, okay? And we're still in that lesson, module 13.1. So standard deviation, it's a measure of spread. And it represents the average distances between individual values and the mean. I think for posterity and recording, I'm going to take off my jingle bells. Okay. So here's the formula. You ready for this one? The formula for standard deviation is to take numbers and figure out how far they are from the mean. See, they use an interesting symbol for mean. Yeah, they use a, looks like a repeating bar over the x. And I'm just copying a formula. And we're going to square that, and then the next number in the data, 2, and then subtract it from the mean of the data. And so on, until you get to the last number in the data. But you're not done there. You're going to divide it by how many numbers. So you're taking distances from the mean and figuring out the mean, and then here comes the fun part. And you take the square root of the whole thing. Okay? Yeah. So in a lot of studies, what they'll do is they'll figure out how far are you away from the standard deviation. What's your standard deviation? And if you're within 1 standard deviation or 2 standard deviations, you're considered normal. But if you're beyond 2 standard deviations from the mean of the data, then you are considered there's a problem. Okay? So let's put this into practice, and you're going to see how much easier this is. I'm going to do with a small group of data. Let me add a couple things here. The x with the bar over that, that's the mean of the data. The x sub 1, x sub 2, and so on, those are the individual values in the data. And n represents the number of items in the data. Okay. All right, so we ready for this one? Okay. All right, so again, we're not going to memorize this formula because I'm going to teach you how to do this in a really easy way. So first thing, we need a set of data. So let's say our data is represented by the April high temperatures. So somebody looked at the month of April, and they took the 5 highest temperatures for that month. And you know, April can go any direction. So 77, 86, 84, 93, and 90. So we're just going to deal with 5 of the hottest days in the month of April. What year, we don't know, we don't care. We just needed a set of data to do things with. So job 1. Find the mean of the data. So you have a couple options how you do mean. You can put the numbers in order from least to greatest. That doesn't really come into play with mean, but some people, it's just a lot easier to add that way. Or you can just list them out. So we're going to just take them and add them together. And we'll divide by how many numbers there are. So off to the side, I'm going to kind of do a little bit of my adding here. So I get 77 and 86. You get 13, 15, and 1 is 16. 84 and 93 is going to give me, what, 177, and then we have the 90. And then we're going to add 163 to 177. So sometimes when the numbers get a little bit larger, it's a little easier if you just do the math off to the side. And we get 340, and then we're going to add the 90 to it. So we get 430 over 5. And so 5 goes into 48 times, or 43, which is 40, goes in 8 times with 3 left over, and 5 goes into 36 times. So what we get is the mean is 86. Okay. Now I'm going to create a chart labeling all the information. Alex.
I have a question. On the test book, are we going to do averages?
Averages and means, yes, that's
Okay.
what we're learning.
Well, so on that question, can we like put 77 and 93 together and
You can add them any way you want.
okay.
There's all sorts of ways to put these together. Okay? All right, ready? We're going to move on. Now I'm going to take that data and I'm going to create a table. So create a table that determines a squared deviation. Okay. Now, before you start freaking out about that, if you go back to the formula, that's what we're going to create. We're going to take our number, subtract the mean from it, square it. Okay? So we're going to create a table that determines squared deviation, because that's what the formula used. So we're going to have the data value, which back in that formula, that's going to represent the x number. We're going to have a column of deviation from the mean. And that's going to be that x sub 1 minus the mean, that x with that fraction bar looks like over the top. And then we're going to get the squared deviation. That's an interesting way of writing that. So I'm going to take the answer I get from the middle column and then I'm going to square it. So that's what I'm going to do with these. So I'm going to take my numbers and I'm just writing them exactly the way that they were given. So it was 77, 86, 84, 93, and 90. Bless you. Okay. So what was the mean that we had on the page before? 86. It was 86. So we're going to subtract that 86 from each of these and come up with our answer. So this one works out to be a -9. Then what I'm going to do is I'm going to take that number that I get and I'm going to square it. And that gives me 81. Okay? And I'm going to do that with the rest of these numbers. So I'm going to take the number from the data set. I'm going to subtract from it the mean for the whole set of data, which is 86. I'm going to take that answer, and in the third column, I'm going to square it. So we get 0.486. Notice that even though I have some negative, when I subtract I get a negative number, it doesn't really matter because in the formula it says you're going to square that number. So here we have -2, and we square that, and we get 4. And then we have 93, take away the 86. And that's going to give us 7, and then we're going to square that, and we get 49. And then the last one, we have 90, and we're going to subtract the mean, 86. We get 4, and we're going to square that, and we get 16. Okay? So if you remember in the formula, it had all of these quantities, the x sub 1 minus the mean, that quantity squared, and we added them all up, and then we divided that by n. And what did n represent? How many numbers we had, okay? So basically what we're going to do now is take this data, and we're going to figure out the mean of that data. Okay, so that's the next step. Everybody good? Can I move on? Yeah? So let's see, we're on step 3. Find the mean of the squared deviations. So for us, we have, this mean is going to be 81 plus 0 plus 4 plus 49 plus 16. And we're going to divide that by 5. So again, however you want to add this up. And what Alex was talking is, can you see two numbers that they're going to end up, when you add them together, giving you a 0 in the ones column? And if you notice, 81 and 49, 9 plus 1 is 10. So we get 12 plus 1, we get 130. And then 4 and 16 is 20. And then we have the 0, which doesn't really amount to much. So we have a total of 150 over 5. And we get 30 is the mean of the squared deviations. Now, there was one more thing that the formula made us do. What did it make us do with this answer? Brian, you remember?
You have to take the square root.
Yeah. So we are going to take the square root of the mean of the squared deviations. And I'm going to tell you that we're going to round it to the nearest tenth. So I'm going to put it over here. So for those of you who did not master when we were doing estimating square roots, it's going to come back at you. Okay, because now you got to do it again. It won't bite you hard though. So remember what the process is. Actually, you know what I'm going to do? I'm going to go onto the next screen and do this. Give ourselves some room. What are the two perfect squares that 30 falls between? Justin?
6 and 5.
Nope, those aren't perfect squares. Okay, Sarah? Nope, those aren't perfect squares. Allison?
36 and 25.
36 and 25. You guys have to answer my question, okay? Now let's take their square roots. So I know my estimation is going to be somewhere between 5 and 6. Okay? So remember we had this process that we have this really cool video. You can go back and watch that video again attached to the homework on estimating square roots. And what we're going to do is 3 subtraction problems. Actually, we only need to do 2 for our purposes. We're going to see what the difference is between our radicand, that's the guy under the radical sign, and the smaller of the 2 perfect squares. Next, we're going to subtract the 2 perfect squares. Now, since my number's between 5 and 6, my base number is going to be 5. To create how far between 5 and 6 it is, we're going to take those 2 numbers that we just got for subtraction and write them as a fraction. And now we have to actually do division. 5 divided by 11. So I put in my decimal point, and 11 goes into 54 times, which is 44, with 6 left over, bring down a 0, and 11 goes into 60 5 times, which is 55, which gives me 5 left over. And if you notice, we're going to have this repeating pattern going on. But the reality is our answer said to the nearest tenth. All I need to do is do 2 digits after the decimal point and then round to the nearest tenth. So the 5 is big enough to round that 4 up, and we would get our answer to be 5.5. So our standard deviation is equal to 5.5. Okay. So the standard deviation has a lot more to do than just calculating range, right? Because range is just real simple. It's just big and small, bam, done. This one, I'm calculating the range. Each item in the data is from the mean of the data. That's the standard deviation. So what they're saying is if the mean was 86, right? Standard deviation would be on either side of this. So I would take 86 and I would subtract 5.5. And so let's, oops, that's between 5. So that would give me 80.5, and I would add 5.5. So I get 91.5. So if you scored 1 standard deviation away from the mean, let's say this is a test grade and the class average was an 86. If you scored in the 80.5 to 91.5 range, then you are in considered 1 standard deviation away from the mean. Okay? That's what we're talking about. Now I can go 1 level deeper, and I can take the 86, and 2 standard deviations would be what? 11, right? Because it's 5.5 twice. So that would give me 75. And then on the 86, and we add 11, we're at 97. So what they're saying is the majority, almost all the students, are going to be between 75 and 97 on that test. Okay? There is a good portion of them between 80.5 and 91.5. Now, if somebody scored below 75 or somebody scored above 97, those may be considered outliers in a way. Okay? But this is what they're talking about, and I'll draw you a picture of it. So if this is your 86, And even though it doesn't look like it, these are evenly spread out. This is your 80.5. This is your 91.5. This number is your 75. And this number is your 97. Okay? So that's what you get to work on tonight. Doesn't that sound like fun?
No. Even for the weekend